Now, in this video, we are going to discuss about how to find the roots of the quadratic equation by using the if statement. So to do that, first we should know what is the roots of the quadratic equation. The roots of the quadratic equation is x1 and x2, wherein you will going to have minus b plus r minus root of b square minus 4ac by 2a. So to find the roots, we need to consider the three variables. Why? Because we have a, b and c. So what is the first is the quadratic equation. The quadratic equation is ax square plus bx plus c is the equation. So where a, b and c are the coefficients. Since a, b and c are the coefficients, if I give the values of a, b and c, I should be able to get x1 and x2 are the roots. So what are the variables you require? The variables required are a, b and c, and the one is the real roots and the other one is the imaginary root. You are going to have x1 and x2. So to find that, now we go through the coding. So first we are going to include all the header files which is required, which is stdio.h, conio.h, and here we are introducing maths.h because we have in the quadratic equation root which is minus b plus r minus root of b square minus 4ac by 2a. Since it is a square root, so to have the square root function, it is there in maths.h. Then we are going to have void main. So we are going to declare the variables now, float x abc, x1, x2 and discriminate value. What is the discriminant value? We are considering as b square minus 4ac. Every time in the equation, if you want to find out, then we need to write b square minus square root of b square minus 4ac. So in order to avoid that, so we are considering that as b square minus 4ac as the discriminant value. Now clear screen, printf, enter the coefficients of a, b and c and read those three variables, which is scanf, percentage of, percentage of, percentage of, and then abc, because the float is the variable which has been declared for a, b and c. So discriminant value is b square minus 4ac, which has been assigned for discriminant disk. Then if this quantity is become 0, then what happens? So you will going to get x1 is equal to the roots are the two roots of the equation. X1 is equal to x2, which is minus b by 2a. Now, so what will be the nature of the root? The nature of the roots are equal, that is x1 and x2 will be equal. So printf, we are going to go for the capital letters of x1, where after the decimal point we are going to have 2 digits. x2, again after the decimal point we are going to control the number of digits after the decimal point as 2, and the roots are x1 and x2. Then if the discriminant value, that is b square minus 4ac, is greater than 0, then the roots are the distinct. x1 will be equal to minus b plus square root of b square minus 4ac. Instead of that, we are going to take that value as disk by 2 star a, and similarly x2 minus b minus square root of disk of 2 star a. Then we have the roots are distinct. So the printf x1, capital X1 is equal to 0.3f backslash n, and x2 0.3f backslash n, of course percentage, comma x1 and x2. If the discriminant value is less than 0, then x1 is equal to minus b by 2 star a, which will going to be the real roots, and then x2 will going to be the imaginary root, square root of f absolute, because f absolute we are considering because the variable what we are considered is a floating variable. So the float absolute of the discriminant value, because if you are getting the decimal point, then we need to consider that decimal point also. So that is the reason why we are considering as f abs discriminant value by 2 star a, that is floating absolute of discriminant value of and by 2 star a. Then printf, the roots are complex. Then the first root is the number of digits after the decimal point is 0.3f plus I percent 0.3f backslash n, x1 and x2. Then the second root is percentage 0.3f minus I percentage 0.3f backslash n, x1 and x2. So then we're going to get the get ch function. Now once you do that, we're going to have the output. So we're going to have the coefficient first. So first we're going to consider 1 minus 4 comma 4. So here a is equal to 1, b is equal to minus 4 and c is equal to 4. If you take that b square, that is 16 minus 4ac, 4 into 4 becomes 16, 16 minus 16 is becomes 0. So that part, that is discriminant value, becomes 0. So minus b by 2a, so that is minus of minus 4 becomes 2, sorry, minus of minus becomes 4 becomes 4 plus 4 by 2. So x1 is equal to 2 and x2 is also equal to 2 because the entire discriminant value will become 0. So the roots are equal, x1 is equal to 2 and x2 is equal to 2. Similarly, when you are considering the coefficients of 1 minus 5 and minus 6, if you are considering minus b, so b square is 25 minus 4 into a, 1 into c, it is 24. 25 minus 24, it becomes 1. So the discriminant value is greater than 1. The roots are distinct, so x1 is equal to 3. And on simplification, you are going to get x1 is equal to 3 and x2 is equal to 2. Then when the coefficients are 6 to 4, you are going to get b square, which is 36 minus 4a is 4a is 24, 4ac, 4 into 6 into 4, 16, 6 4 is 24 into 4, which will be 96. So 96 minus whatever the value you are going to get, which will going to be in the negative form. So naturally the roots are complex. Here x1 will be equal to minus 0.167 plus I 0.799 and x2 minus 0.167 minus I 0.799. So this is how we will be able to find all the three different types of roots. One is the roots are equal and the other one is roots are distinct and other one is the roots are complex. Now we need to find out the roots by coding. So we will go for the Turbo C compiler and then we will going to write this program. So to do that, so here first I will go for include stdio.h, then include conio.h, okay, then include math.h, then we have void main, then we have float x1, a comma b comma c comma x1 x2 and discriminate. Then we have CLR SCR, then we have printer. Enter the coefficients. Of course, it should be A, B and C. If you want, you can write that. Otherwise, you can say simply percentage of ampersand A, comma, ampersand B, comma, ampersand C. Next. Then we have discriminant. We want discriminant will be equal to B star B minus 4 star A star C. Then if discriminant equals 0, then condition is true, x1 equals x2 equals minus b by, if you want you can keep it in parenthesis, by 2 star A. Then we have printf, then we are going to get the roots are equal, \n. So printf, then x1 equals percent 0.2 f \n, then x2 equals percent 0.2 f \n, then we will have x1 and x2. Then we have closed this. Then we go for if discriminant is greater than 0, that is the positive value, then x1 will be equal to minus b plus sqrt discriminate by 2 star a, then x2 equals minus b minus sqrt disc by 2 star a. Then printf, the roots are distinct \n, then printf x1 equals percent 0.3f \n comma okay, then x2 equals 0.3 percent 0.3f \n comma x1 comma x2. Then close it. If discriminant is less than 0, then x1 will be equal to minus b by 2 star a, then x2 equals sqrt f absolute discriminant by 2 star a. Then printf, the roots are complex \n, then printf x1 equals the first root equals percent 0.3f \n or 0.3f, the first root having the real and as well as I percent 0.3f \n, then we have x1 comma x2, then printf, the second root which will be equal to percent 0.3f minus I percent 0.3f \n, then we have x1 comma x2. Then we have the getCH function, then you close it. Once you do that, the roots are the coefficients which we want to enter. I will take 6, then 2 and 4. The roots are complex. Now we will try to execute this by using F7. Then we have the coefficients. We are going to read those coefficients. I will take 6, I will take 2 and I will take 4. Then it comes to this discriminant greater than 0, discriminant less than 0, the quantity f absolute, the roots are complex. Then the first root it will print the second root and get ch function. So you are going to get this. So this is how you are going to execute this program. Now when you want to go for the second case, enter the coefficients. I will go for the first one, 1 minus 4 and then 4, enter. Then we go for the discriminant value to calculate. If it is equal to 0, yes, then it will execute this. The roots are complex. Yes, it goes for the printf where it finds the x1 and x2. The roots are equal. Yes, it checks for the discriminant, that is value is greater than 0, no, value is greater than less than 0, no. So its roots are equal. So the second root we have obtained. Then we go for the last coefficient. Then we have the enter the coefficient of 1. We go for minus 5 and then 6. Then enter. So it calculates the value of discriminant value. It is equal to 0, no. Then it comes to greater than 0, yes. So it calculates the value of x1 and x2 and then the roots are distinct. And then it prints those values of x1 and x2. Then it skips and gets a function. So therefore x1 is equal to 3.00 and x2 is equal to 2. So this is how you will be able to calculate the roots of the quadratic equation by using the if statement. So finally I will going to quit. I will say no. So finally it will comes out. So this is how you will be able to execute this program on the quadratic equation by using the if statement. Thank you.